question is, what is red light therapy and near-infrared light therapy, also known as photobiomodulation? Now, I know it's not popular for many people. So here's the explanation. Red and near-infrared light are part of the electromagnetic spectrum, and more specifically, part of the spectrum of light emitted by the sun and also firelight. And by fire, they mean wood-burning fires, coal-burning fires, naturally burning fires. These wavelengths of light are bioactive in humans. That means that these types literally affect the function of our cells. So what's all of this talk of electromagnetic spectrum and spectrum of light? Let's take a look at the electromagnetic spectrum so I can show you more clearly what I'm talking about. And then you'll get here, when I scroll down, the visible spectrum. Let's see if, oh, there we have it. So you could see in this spectrum from 400 nanometers to 700 nanometers, a very small spectrum of possible light is visible by the human eye. And you can see visible light there. It doesn't mean that there isn't more light. It means that's all we can detect, which, as you can see, is a very narrow band. Now, some gifted people and saints and saintesses can see a lot more, but the majority of us, we just fall into that very narrow band. And there it explains the range and shows how the colors can be seen when it's put through a prism. Prism breaks up the light. So as it says, if you pass white light, like sunlight, through a prism, it'll separate out the different colors based on their wavelengths. This is how we get rainbows as well. And you might remember this from school with the acronym ROY and G, red, orange, yellow, and green, blue, indigo, violet. A tiny part of this spectrum, from the roughly 400 nanometers to 700 nanometers, is visible to the human eye, as I said before. At the highest end of the visible spectrum is red light, which goes from a little over 600 nanometers to approximately 700 nanometers. Above the visible light spectrum is near infrared, and from above 700 nanometers to a little over 1,100 nanometers. It is the red infrared wavelengths specifically that have the amazing effects on our bodies. Interestingly, even within that range, not all the red and near infrared wavelengths seem to be created equal. Specifically, most research showing benefits of red light to near red light have used wavelengths in the narrow range of 630 to 680 nanometers and 800 to 880 nanometers, while most other wavelengths of light, such as ultraviolet, blue, green, and yellow light, etc., are mostly unable to penetrate into the body and stay in the layers of the skin. Near infrared light and red light are able to reach deep into the human body, several centimeters and close to 2 inches in some cases, and are able to directly penetrate into the cells, tissues, blood, nerves, the brain, and into the bones. Now, this point of the brain is very interesting to me, because currently the gene therapy trials that people are taking involuntarily cross the blood-brain barrier, so it's good to know that the red light treatment I offer here will penetrate into the brain to help break up some of the gene therapy negative aspects. Now, once in those deeper tissues, red light and near infrared, also known as NIR, light have incredible healing effects on the cells, where they can energy, modulate inflammation, relieve pain, help cells regenerate faster, and much more. So we wondered, why doesn't everyone know about this? Two big barriers specifically have hindered the widespread adoption of this technology by the general public. One, until recently, it was thought that you needed an expensive machine. Two, red and near infrared therapy light-emitting diode panels are also being used in anti-aging clinics, where people are being charged a lot of money. Shockingly, new research have shown that it is not necessary to use these expensive laser devices. In short, you could get them a lot cheaper on the internet and have them in your own homes. Here's what Harvard researcher Michael Hamblin, PhD, widely regarded as the world's top authority on photomodulation, has to say on this subject. He says, even if you buy a cheap lamp, you have the same medical benefits. I'm paraphrasing for you, saving you having to read it all. But that's what he says in short, only because we went through this last week. So you don't have to spend a lot of thousands of pounds of money on it. Right, now, the 5 bioactive types of light, why humans need sunlight to be healthy. And remember, we have negative effects from gene therapy. Justice and clinical trials, they presume to be a tested vaccine. Just as human cells need nutrients from food, light is also a necessary nutrient for our cells to function well. Certain wavelengths of light can help power up our cells, affect hormones and neurotransmitters, balance our mood, enhance physical alertness, improve sleep, and positively affect the expression of our genes, which is a topic in its own right, referring to epigenetics, which means of the genes. So contrary to what the government was telling us, oh, you must only be out for 1 hour. Quite the opposite. The human body needs light to be healthy, and both the right. This may seem like a strange idea at first, as we're generally not used to thinking of light as playing an important role in our health. We're used to thinking of light as what we turn on in our house so we can see, or the headlights of our car that allows us to drive at night. Most of us are deeply unaware of the fact that many different types of light are bioactive in humans, which means they affect the functioning of human cells, and that our health is largely influenced by the dosage of the different types of light that we get each day. Now, I know a lot of you from the Indian subcontinent would know much about rickets when you see bow-legged people. Now, they are born into sunlight because the Indian subcontinent is a place of very bright light, yet some disorder has taken place where they're not taking up the activated vitamin C by the sun, and rickets are coming about, and you see this very distinctive bow-legged situation. Now, there are 5 types of bioactive light in humans, and even though he doesn't highlight it here, you have blue light, which is very bad for your eyes. That's all these mobile screens and computers and so on. Ultraviolet light, used for sterilization and so on. Far infrared for healing, red light for healing, and near infrared for healing. Most modern humans are deficient in the benefits of all of these 5 wavelengths of light. And just as there are health consequences of not getting enough of the light, nutrients in our diet, malnutrition, there are health consequences when we don't get enough of the right light, mal, illumination, not enough light. Mal is the Latin. What kind of health consequences, you wonder? Well, here are two well-known examples of how light deficiencies and imbalances impact human health in profound ways. Sunlight deficiency and vitamin D. Now remember, you can supplement with vitamin D. Everyone who's in the northern latitude, in where we are here in the north, that's from John O'Groats to Land's End, the whole of the British Isles, do not get enough sunlight to produce substantial activated vitamin D. I talk to a lot of people who say, oh, I don't take vitamin D supplements in the summer. Well, one research I saw said, and I digress from the reading, if you at midday stand up and you have no shadow, you have enough sunlight. But I could tell you that means that the sun is directly overhead. I could tell you now in the north, the sun is only 3/4 of the way up in the sky. So at midday, it casts a shadow. You're not getting enough sunlight for vitamin D. Therefore, logic says, you must supplement with vitamin D all the year round and still go out into 3/4 high sunlight and get as much of that as you can. Some say 20 minutes to 30 minutes, but that's for, I think, where it's hot. Us, you could stay out in it all day, you won't have a problem, except on very hot days and if you have very light to white skin. Now, for those who are new to the Northwest, if you look at the horizon when the sun rises and at midday where the sun sits in the sky, as winter comes on, you'll see it barely rising over the horizon. It doesn't rise high. Come summer, it doesn't ride up so that it sits over your head. Now, let's look at the pathologies now. So neurodegeneration disease, so your neurons are in your brain, they're the things, the synapses that fire. And when they are affected, you have Alzheimer's, dementia, multiple sclerosis, and Parkinson's. Dozens of types of cancer, so they're not listing them all there. Obesity, so this thing of inability to lose weight because your body is not functioning at peak, or in fact is quite sluggish. Diabetes, so that's regulation of blood sugar, metabolic syndrome, and heart disease. There is even research that suggests that low levels of sun exposure are a risk factor for human health, equivalent to that of being a cigarette smoker. A Swedish study looked at nearly 30,000 women for 20 years, which is a good study. Note, studies with this many people that are this long-term are exceedingly rare, meaning it's a good study, and found that women with the lowest sun exposure had 2-fold higher rate of death compared to the women with the most sun exposure. So even though it's cold out here in the north, get out in the sun and get as much of your skin facing the sun as possible. That's another example of illumination. Artificial light exposure at night from electronic devices like phones, TVs, computers, indoor lighting have been linked with numerous diseases like the various forms of cancer, depression, fat gain, obesity, diabetes, metabolic syndrome, insomnia, and poor sleep, which I believe means the same thing, but maybe not. Insomnia, you can't sleep at all. Poor sleep, when you can sleep, you're not sleeping well. And mood disorders, which would mean being grumpy, fragility, and so on. For those who don't know what those terms mean, it just means your moods are not stable. And this is just a few of the dozens of health problems linked to not having enough of the correct light. So many of you may be looking to other probable causes for your various symptoms, when in fact a lot of them are linked to dehydration and lack of proper illumination. But what if I told you that there is another kind of light deficiency that most people are totally unaware of, and that is likely even more problematic? Near infrared and red light deficiency, which is what I've been talking about. Red and near infrared light have profound effects on our cellular and hormonal health. And I know for all the women who are listening, hormonal issues are very close to your heart. And we're designed to need ample amounts of these types of light to have optimal health. Just as the modern world of processed foods leads to chronic malnutrition, our modern light environment, brackets of too much of the wrong kinds of light, which I mentioned the blue light and white light before, and too little of the right kinds, and with poor timing, it's called mal-illumination. The vast majority of people living in the modern world are suffering from chronic mal-illumination and don't even realize. And it has widespread effects on our brain and organ functions, immune system, energy levels, mood, neurotransmitter balance, and hormone levels. So when you're all feeling a bit unstable, just think, I need red light, I need near infrared light. So for the next 10 minutes, I'll stop at 7:30 so we could move to questions. So the heck does red and near infrared light actually cause these effects? We know how ultralight affects us. For example, it works primarily interacting with our skin and stimulating the production of vitamin D. We also know how blue light enters our eyes and feeds back into the circadian clock in our brain in the suprachiasmatic nucleus to regulate our 24-hour biological rhythm, including the complex array of hormones and neurotransmitters that are regulated by this circadian in our brain. I'll go back over that. Circadian rhythm basically means pre-industrial times when the sun goes down, the animals go to sleep, the human goes to sleep. The sun rises, the animals wake up, and we wake up. So it's a sensitivity to light and to dark. When it gets dark, melatonin flows. When the sun begins to rise, serotonin flows to dissipate the melatonin, and we jump up and we're awake. So that's the circadian rhythm. That's what we're referring to. Now, these mechanisms are well understood by science, but what about red or near infrared light? There are numerous different physiological and biomechanical mechanisms that researchers have identified as being affected by red and near infrared light. But for our purposes here, this is not an article meant for academics, but for regular people wanting to benefit from red and near infrared light. I don't want to get too bogged down into the details of dozens of different molecular signaling pathways at the cellular level. Instead, I want to keep things as simple and easily understandable as possible. To give you an idea of what I mean when I say that things can be complex, here is a short list of biomechanical pathways that have been proven to be altered by red and near infrared light. So this may be a little bit technical. In fact, it is a little bit technical. He warned, but he's given you a few examples. So cytochrome C oxidase, these are pathways in the body or the brain. Retrograde mitochondrial signaling, the mitochondria is within the cell. Light sensitive ion channels, that is within the cells. Adenosine triphosphate in the cells, which I happen to know. Cyclic AMP, having a clue. reactive oxygen species is within the cells, and obviously is to do with the blood, the oxygen take-up molecules within the cells and the cell internal barriers, calcium and calcium channels, also to do with the cells, nitric oxide, also to do with the cells, nuclear factor kappa B will no doubt to do with the cells, RANKL, you'll have to look that up, hypoxia inducible factor. Now, everyone going around wearing masks are contributing to HIVA, okay? Which is the depletion of oxygen in your cells and the increase of carbon dioxide. AKT stroke GSK3B stroke B catenin pathway. Catenins, I know, is to do with pain. CAT, short for that North Africa, the Horn of Africa is popular with, as a painkiller that they chew. So the same, catenin is the same. AKT stroke mTOR, cyclin D1 pathway. I know of mTOR, so again, we're always talking about at cellular level. Stroke FOXM1, PPARY, don't know, but you can look them up, but they're all pathways. And so we go on. Now, transforming growth factor, you all know that, you know, you're born and you grow, things grow, cells grow, etc. You have to grow new cells or new parts, so that's your growth factor there. Pro and anti-inflammatory cytokines, you'll hear about this from this new gene therapy, that they activate in your immune system a cytokine storm, and there you have them as a response to inflammation. As you see there, it's anti-inflammatory. That's how the body deals with invaders. Vascular, that's your blood system. Endothelial growth factor, that's a thin layer of skin within your body. Anyone who's eaten hot food and the roof of their mouth is burnt, you've burnt your endothelial cells. Okay, now hepatocyte, the HEPA is your liver, so it's the growth factor in your liver. Basic fibroblast growth factor and keratinocyte growth factor. So fibroblasts grow bone, keratin, that's to do with hairs. Heat shock proteins speak for itself. So, in other words, responding to a burn. Melatonin, mel means black. It's a black fluid issued in the brain to help you to sleep. Hence the phrase, for those who are familiar with English, mellow, 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 means you're mellowed out, you're heading off to sleep. Brain-derived neuropathic factor speaks for itself again, so it's derived in the brain, a neurotrophic factor. So that's just a few of the technical stuff that you could all look up. Rather than talk details of different biomechanical pathways, let me simplify the major mechanism of red stroke near infrared light on our body. So for the next 2 minutes, 2 mechanisms. Oh, lovely, you have an example of a cell. I generally think of photomodulation as having 2 central mechanisms in how it benefits cellular function and overall health. One, stimulating adenosine triphosphate production in the mitochondria through interacting with a photoreceptor called cytochrome C oxide, which started the list. Now, ATP is what gives you energy, so you could get up and do things. Anytime you have chronic fatigue syndrome, it means your ATP production has a problem. Creating a temporary, so we're going to number 2 now, creating a temporary low-dose metabolic stress that ultimately builds up the anti-inflammatory, antioxidant and cell defense system of the cell, known as hormesis, which is also a primary mechanism of why exercise works. And I always lecture quite a bit when people love over-exercising, and I say it creates stress in your body and triggers anti-inflammatory response. So at the right levels, exercise is good. And when you do it too much, this hormesis works against you. And there you have it there. And at that point, I'm just going to read this example for you, the cell diagram, before I stop. So it's showing you there, mechanism 1, increased mitochondrial energy production, which is what I said. So those two red items, your mitochondria, the fuel in there is the ATP, the adenosine triphosphate. So anyone who's feeling a bit sluggish, immediately ATP. Why? How do inflammatory defense system, which is just fantastic, because that helps with, and then he goes on to break it down in detail, but we're out of time now, and it's a detailed study, and you could all look it up online because I've already shared the source of this. Okay, Amal, you can open up for questions now. Ozone. Yeah, you could use ozone. You could use a silver, additionally, use a silver mesh filter. And lastly, you put it through ultraviolet pipes. Now, in Sewage Works, they do all of those things, and certainly two of them. I've got a friend who works with the water company, and when I mentioned that I ozonate my water, we ozonate the water as well to kill bacteria. But I already know from my research that, look, to clean a fish tank, they put the water through an ultraviolet filter to keep the fish alive. And then the ozonator, you'll see in fish tanks, these things bubbling, aerating the water. So when you have the combination of all three, that's the healthiest thing going. So yes, it's the best thing. If you could get ultraviolet cleaning, that is wonderful.